Hello everyone, and we are back on our track that our technical problems. Okay, so today we will see one question of thin cylinder. Okay, that has been asked in GATE 2020, and that is very unique question because it is a combination of machine design, or we can say that cylinder design. Okay, thin cylinder design as well as thermal stress. Okay, so this is very unique. It is a combination of two subjects question. So let's see what the question is. So the question says a thin walled cylinder of radius r and thickness t. It is open at the both ends and the fits snugly between two rigid walls under the ambient condition as shown in the figure. That means this is the two rigid fixed supports, rigid wall here it is given, and there is a pressure vessel held between two and at normal condition. Now some material property is given. Young's modulus is given, Poisson's ratio is given, coefficient of thermal expansion is alpha. What is the minimum temperature rise of the cylinder? That means assume uniform cylinder temperature, no buckling. That means here there is no buckling is there, and uniform heating. The uniform cylinder temperature, that means uniform heating, so that no thermal stress is produced. Okay, and so what is the delta T that we have to find to prevent gas leakage in the cylinder? Okay, and which is stored at pressure P. There is a gas stored here in the cylinder at pressure P, which is above the atmospheric pressure. Okay, so first of all just first of all we will use some of our common sense. Like if there is a fluid pressurized fluid filled here, and as we increase the temperature, so the pressure will also increase because volume is constant within the, because this is fixed, so cylinder volume will remain constant. So it will try to push this outward like this. If I am drawn next page, the cylinder like this, if this is a cylinder and this is fixed at the both the ends, so what happened, as we increase the temperature the pressure will increase, and it will try to push this cylinder from this. So there will be hoop stress generated from, if you see from the cross section like this, so there are hoop stresses. So it will try to increase bulging out, so it will try to create like this bulging shape, but there is no buckling. So what happened, so whatever the stress generated due to hoop stress, so generated due to inside pressure, the hoop stress is generated, and to prevent this bulging, the longitudinal strain, that means in this direction, in longitudinal direction a strain will produced. Okay, though they are, though the cylinder is fixed in longitudinal direction, but there will be some strain, and if it is crossed the safe limit, then there may be brushed anywhere, and cylinder will burst out, and all the fluid that is filled, that will be leaked out. Okay, so that is the failure condition. So what will be our condition? That is the thermal strain produced due to thermal temperature Et, I am writing with Et, it should be equal to longitudinal strain. Okay, why longitudinal strain? Because it should be at maximum condition within the safe limit, nothing will happen. But, or more precisely, if we can write here, that is thermal stress is equal to maximum of longitudinal strain or hoop strain. Okay, but hoop strain is, it will try to bulge out, that means there is a buckling, but here it is said that buckling is prevented, so this hoop strain will be cancelled out, so only one will remain. So thermal strain is equal to longitudinal strain. Okay, and we know the, as per the Hooke's law, strain is equal to stress upon modulus of elasticity. Okay, and now the stress due to inside pressure, because this is the fluid that is pressurized at P, So stress due to inside pressure, that is P d by 2t. This is okay. This is the stress due to inside pressure, and we can write d by 2 as a, this is the hoop stress. Okay, this is hoop stress. Why I'm writing hoop stress, not longitudinal stress? Because in longitudinal direction there is no stress, because this is fixed, but due to hoop stress the longitudinal stress is produced. Okay, so that's why only stress that is produced is hoop stress. Okay, so hoop stress is like this, PD by 2t, and strain in longitudinal direction, that means perpendicular in the other direction, that is we can write minus mu into PD by 2t. Understand what I have written? That is, I use the Poisson's ratio, lateral strain upon linear strain. Okay, so lateral strain from hoop stress I can find a hoop strain, but hoop strain is not bother to me. The only thing that bother me is longitudinal strain. So from longitudinal strain, it is in linear direction and it is in lateral direction, hoop stress. So we can write Poisson's ratio mu like a lateral strain upon linear strain. Okay, so lateral strain, that is PD by 2t, lateral stress, and I have multiplied with mu and divided by E. PD mu into PD by 2t into E, because the stress that is produced here, because no stress will produce because this is fixed. Okay, so whatever the pressure increase, that will be compensated by support reaction. Okay, so only this is only in this direction, hoop stress, circumference direction, there is stress, and but there is no bulging is said. So the strain will be in longitudinal direction. So strain in longitudinal direction, ultimately I can write here again, strain in longitudinal direction minus mu times PD by 2 into T is the thickness and E is the modulus of elasticity. Okay, hope you understand what I have done here. That is, I have first, let me write here, hoop strain, that is hoop stress by modulus of elasticity, but when we go into lateral direction, that is minus mu into hoop stress by modulus of elasticity, and just I have put the hoop stress value from here. Okay, so I got longitudinal strain because as I explained you earlier, so the thermal strain, that is minus mu times P d by 2, I can write the R, radius of cylinder, into T into E. Okay, minus mu P into R divided by TE. Now the thermal strain, that is thermal stress, divided by modulus of elasticity. So what is the thermal stress? I can write here, that is E alpha delta T. E alpha, alpha is coefficient of thermal expansion of the cylinder material, and delta T. Here EE will get cancelled, and here minus mu times PR into TE. Why here minus? Because it represents the direction. Okay, so if the bulging will happen, then the longitudinal direction will be try to uh, tends to compress. Okay, so we will neglect this minus sign, so we can write delta T is equal to mu P R by alpha into T into E. Okay, here alpha is what? Thermal expansion coefficient of the cylinder material. So this is the answer. This much temperature should be increased to prevent the buckling and the leakage. So what's the our option? That is, here small v is written, here small nu, or you can say that nu, but I have taken as a mu here. So option C will be right answer. Okay, hope you guys understand. If you still any doubt, ask in the comment section. We will solve in upcoming videos. Okay, so keep studying, stay focused.